Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to talk about how we can estimate derivatives or find them using a calculator. So for estimating derivatives, we've done a little bit at Unit 1 with estimating the rate of change from a table, and that's basically what estimating derivatives is. You want the rate of change on as small of an interval as possible that you can find in the table. So let's look at these example problems. The tables below show the total distance traveled by Sunny and Gizmo at various times t. So there's two different parts to this. Using the table below, estimate Sunny's velocity at t equals 3, 7, and 9. So we have this table of Sunny's position. We want to find her velocity. We want to find 3. So 3 is right in between 2 and 4. And the interval from 2 to 4 is pretty small. So we can just say that we have the change in y over the change in x. That's going to be 9 minus 5 over 4 minus 2. So that's 4 over 2, or 2. So our velocity is around 2 meters per second. Now at 7, that's going to be right in between 6 and 8. So that's 15 minus 11 over 8 minus 6. That's also going to be 4 over 2, or around 2 meters per second. And then at 9, it's going to be between 8 and 10. So we have change in y over change in x. 21 minus 15 is 6. 10 minus 8 is 2. We have 6 over 2, around 3 meters per second. Now, the second problem is we want to estimate Gizmo's velocity using this table. So we're going to do the same thing, the difference in y over the difference in x. And we want it at 1, 5, and 11. So at 1, we go right in between 0 and 2. So 3 minus 1 over 2 minus 0, that's going to be 1. And then in between 6 and 4, that's where we're going to get t equals 5. And we have 9 minus 5 over 6 minus 4. That's 4 over 2, so 2 meters per second. And then finally, at t equals 11, it's going to be between 10 and 12. So difference in y is 31 minus 23, that's 8. And the difference in x is 12 minus 10, it's going to be 2. So it's 8 over 2, or 4 meters per second. Now let's try one where we need to use a calculator. So Jackie flies across the graph of x squared sine of ln x squared over x cubed plus 2x, starting at x equals 1 and flying to the right. What is the slope of Jackie's flight the first time her y position equals 0.25? So this one's a little challenging, but we have the calculator, and on the AP test, you're allowed to use Desmos because it's on the computer. So let's see what this is asking us. First, we need to find the first time our y position equals 0.25, because it doesn't give us an x value. We need to solve for an x value. So we have this function graphed out on Desmos here, and we want to find the first time that Jackie's y position equals 0.25. So we're going to input in the line y equals 0.25. And now you can find the places where this line crosses the graph. So we're starting at x equals 1, and Jackie's going to fly up here, and you can see the first time she's going to run into this line is at x equals 1.48178. So we got x equals 1.48178, 1.48178, we want to input that line into Desmos. Now there's two ways you can find the derivative of this. If you put this function in parentheses and just type in d over dx, that will give you the derivative. And now we use our line that we inputted, x equals 1.48178, and zoom in to where the derivative intersects this line. And we can see that the derivative equals 0.328. And on the AP exam, well, it's actually 0.3288. On the AP exam, we want to round to 3 decimal places. So that's going to round to 0.329. And that's one way to find the derivative. But there's actually another option for finding the derivative using Desmos. If we take this function and we set it equal to f of x equals whatever function we have, if we put f prime of x, we just type in f prime of x right there, that will also give the derivative. And you can see that if you look at that intersection point, it gives us the same answer. So that's it for today, and I'll see you again